All right, well, congratulations, because you are on the harder level question here. How many grams are in 2.1 times 10 to the 21st atoms of Ba barium? The reason this is a higher level is because it's actually 2 steps. So how many grams? That's what I'm looking for. Are in 2.1 times 10 to the 21 atoms. You do have to remember that atoms can be used interchangeably with molecules. So this is where we're starting. There's no path that gets you from molecules to grams without first going through moles. That's why it's written this way. So the first thing you have to do is use 6.02 times 10 to the 23rd to get to moles. And then to go from moles to grams, use molar mass. So because we're doing 2 steps here, our work is a little bit more complicated, and our tool is gonna have 2 vertical lines because it's 2 steps. But before we start filling this out, I want to write our relationships. So we know that we're gonna have to use the 6.02 times 10 to the 23rd. So I'm gonna write that down the 2 ways that we could use it. Remember, with all of these, they can be flipped. I am using the unit atom because it's not technically a molecule because it's just a single element. Okay, so those are the 2 ways that we could use that one. Now for the molar mass, it's for barium. So I'm going to have to look on the periodic table and find out that barium has a mass of 137.33. Or I can flip that. Oops, grams. So this is kind of combining the other videos that we've been doing here. Just so you know, barium's here, has a mass of 137.33. Okay, so these are the 2 relationships that we can use depending on how we're setting this up. Just like with every problem, you start with your given. Your given was that 2.1 times 10 to the 21st atoms. So I'm going to try and keep everything on the screen. 2.1 times 10 to the 21st atoms. Just like before, nothing goes here. Now if the unit atoms is here, we have to put the unit atom down here. If I look at blue, there's no atoms. I have moles and grams. So blue is not what I want, which makes sense because I'm starting here, which means my first step is to go to moles, so I'm using the 6.02. So the green is what I need here. Now I need atoms on bottom. This one has the atoms on bottom, so this is the one I use. Not this one, because this has moles on bottom. Remember that this line right here is the same thing as this line. So I just take it and I copy it. I put the 1 mole on top. There's the black line, and I'm going to put 6.02 times 10 to the 23rd down here. Now I have mole on top. That means I need mole on bottom. So I've already used the green. I'm not going to use it again. I've already used it. I've already copied it. We're done with the green. So it's the blue one. I hope that y'all can see the colors on there. If mole is here, mole has to be down here. This one has grams on bottom, not the one I want. This one has mole on bottom. That's the one I want. So I take it and I copy it over. Remember, this line right here is the same as this line right here. So I copy it over, and I'm going to double check that all of my units cancel. Atom, atom, mole, mole. Last unit is grams. That is the unit on my answer. I'm going to pick up my handy dandy calculator, and I'm going to plug in 2.1, but I'm not going to hit the times 10. I'm going to hit second EE, 21, times 1, because I always multiply the top numbers, times 137.33. If it's on bottom, I hit divide. So I'm just going to hit divide. 6.02, second EE, 23. Divide, because it's on bottom. So I'm going to hit divide by 1. And I'm going to hit enter. There's my answer. 0.48, because I'm rounding. The last unit I wrote down was grams. This is the more complicated one. It is 2 steps because you were starting with molecules and you were ending with grams. So you had to use both conversions, both relationships. The 1 mole is 6.02 times 10 to the 23rd. And you had to use the molar mass off the periodic table, which for barium was 1 mole is 137.33 grams.